Welcome back. This is part 2 of distribution, properties of distribution function. In the last class, in part 1, we have discussed 6 important properties of distribution function as well as definition of distribution function. Now we discuss another important property of distribution function, which is the biggest one. So therefore I consider in the another part. What is the property? If f of x is the distribution function, then certain property f of minus infinity is equivalent to 0 and f of infinity is equivalent to 1. This is what we have to prove. To prove this property, but I consider the sample space S. The sample space S is a union of countably finite number of countable number of events, disjoint events. I consider the sample space S as a countable number of union of countable number of disjoint events. But I consider countable number of disjoint events and I consider their union. That is nothing but S I consider. So S is nothing but, you see, I consider in this fashion. Union n is equal to 1 to infinity minus n less than x less than or equal to minus n plus 1. This is the first one I consider. And the union of n is equal to 0 to infinity, n less than x less than or equal to n plus 1. Probably why I have considered this also you may understand easily, because it is very distinguished particular property. The property number 1, probability of a less than x less than or equal to b. In that fashion I have considered minus n less than x less than or equal to minus n plus 1. N less than x less than or equal to n plus 1. So therefore I consider in that fashion. So first of all I prove that, I indicate and I explain that how they are disjoint. If only disjoint events are here. First of all my question is, I take one by one. N is equal to 1. If you consider n is equal to 1, then here it is minus 1, which is not included, and minus 1 plus 1, that is 0. 0 is included. Whenever I included, I write a closed bracket, not included, open bracket. Okay? And then you consider next one, n is equal to 2, then it is minus 2, and minus 2 plus 1, that is minus 1. Okay? It's not included, it is included. And so on, you see here. Here the minus infinity is some particular value here. Okay? You consider I am leaving. Come over here. N is equal to 0. 0 is not included. And n is 0 plus 1. That is 1. 1 is included. And take n is equal to 1. And 1 plus 1, 2. It's not included, it's included. And so on. Infinity somewhere the set you have. So from minus infinity to infinity, I have considered different events which are disjoint. How? You see here, minus 2 is not included, minus 1 is included. Minus 1 is included here, minus 1 is not. Minus 1 is included here, minus 1 is not included here. 0 is included here, 0 is not included here. 1 included here, 1 is not included here. Like that, so therefore every particular set you consider or the event you consider, all the events are countable, all the events are disjoint. So now I have considered union of all the events from minus infinity to infinity as in the sample space S. The sample space S I have divided into union of countable number of disjoint events. Union of countable number of disjoint events. Is it okay? Then I start the property. So this is what just the statement of this particular S. S is nothing but it is expressed as union of countable number of disjoint events. Which are countable? Remember that which are countable. So otherwise how can we specify it? No. So therefore the countable, right? It's equivalent degree. Now I consider probabilities on both sides, right? That is probability of S is equal to probability of right? Probability of union n is equal to 1 to infinity minus n less than x less than equal to minus n plus 1. Union n is equal to 0 to infinity n less than x less than equal to n plus 1. So this is one another particular one particular disjoint event. This is another particular disjoint event. Probability of, let me consider A and B, A union B. Probability of A union B can be expressed as probability of A plus probability of B for A and B are disjoint events. So therefore I am expressing as this is nothing but probability of union n is equal to 1 to infinity minus n less than x less than equal to minus n plus 1. This is one particular event. Probability of A plus union becomes plus. Its probability of union n is equal to 0 to infinity n less than x less than equal to n plus 1. So this is another disjoint event from 0 to infinity. It is minus infinity to 0. So therefore by considering that here are probability of union n is equal to 1 to infinity many number of union of many number of disjoint events. This is again probability of union of many number of disjoint events. So therefore if you consider again the probability of union I is equal to 1p AI, for example, A1, A2, AN are disjoint events, then it can be expressed as summation I is equal to 1 to n probability of AI. That is the one of the axiomatic definition of axiomatic definition of probability. So the axiomatic definition, by using the same kind of axiomatic definition of probability, the same we have used for A union B. Now here we are using for A1 union, A2 union and so on union AN. The summation union I is equal to 1 p n. I write here property here. Probability of union I is equal to 1 p n AI that can be expressed as summation I is equal to 1 p n probability of AI when A1, A2, AN are disjoint. We can write probability of union as summation. So I am writing directly by using the summation. That is probability of union. I am expressing as summation. Summation I is here n is equal to 1 to infinity. Probability of minus n less than x less than equal to minus n plus 1, that is first one, and the plus again probability of union I am expressing as summation n is equal to 0 to infinity and probability of n less than x less than equal to n plus 1. These are disjoint events. Since they are disjoint, we can express as probability of union can be summation probability. Probability of union, since they are disjoint, it can be expressed as summation probability. Right? Now you express each and every one, okay, in terms of the distribution function. Use the property of distribution function now. Probability of A less than x less than b, less than or equal to b, and probability of A less than x less than or equal to b again. So that property can be written as summation n is equal to 1 to infinity f of b minus f of a. B is minus n plus 1, minus n plus 1 minus f of a, that is minus n. And then summation plus summation n is equal to 0 to infinity. This again probability of a less than x less than equal to b. B is n plus 1, f of n plus 1 minus f of n. So, right? This is what the property of distribution function. I have used property number 1 of distribution function. Now I expand the terms now. Hope you understand. Now tell me what is the answer of the probability of S? It is 1. So therefore now I am expressing this particular value, right? And to prove this, f of minus infinity is equal to 0 and f of infinity is equivalent to 1. I have considered this S is union of countable number of disjoint events and which takes the values from minus infinity to plus infinity. I have considered the sample space S, the limits of the sample space S from minus infinity to plus infinity, the entire real number system, right? So now This now you express 1 is equivalent to b. Now you express n is equal to 10, take n is equal to 1, substitute n is equal to 1, expand this, n is equal to 1, then minus 1 plus 1, that is f of 0. You write clearly, this is f of 0. For every two particular terms I put a bracket so that you can understand. Minus 1 plus 1, 0, and minus 1, minus of f of minus 1. This is the first one. Okay, next. Substitute n is equal to 2, minus 2 plus 1, minus, not minus plus, f of minus 2 plus 1, that is f of minus 1, minus f of minus 2. Substitute one more term, n is equal to 3, f of minus 3 plus 1, minus 2, minus plus, minus f of minus 2, minus f of minus 3. Plus and so on. The last one, substitute infinity, minus infinity plus 1, minus infinity. You keep as this plus f of minus infinity plus 1, minus f of minus infinity. Okay, plus. Now the next term starts. That is, I have written all the values of the first term in the first line, and coming to the second term, summation n is equal to 0 to infinity in the second line. Right? Now again plus. Now the substitute n is equal to 0. F of 0 plus 1, that is f of 1. F of 1 minus, this is f of 0. Plus, again you substitute n is equal to 1. 1 plus 1, 2, minus 1. That is f of 2 minus f of 1. Substitute one more. N is equal to 2, 2 plus 1, 3, f of 3, minus f of 2, plus and so on, plus. Last one, let me consider infinity, f of infinity plus 1, infinity plus 1, minus f of infinity. Do you understand this? These are the two particular, in the first line we have all the terms of first term, in the second line all the terms of second term. So that is a total of all the terms. Now you see in which pattern the terms are going to be cancelled. Don't worry about it. The only two terms remaining, all the terms will get cancelled. Right? So first of all, you see here, you observe the pattern in the first particular term. So you see here, I have taken this is one particular term, this is another particular term, in which second term and the first term minus plus is going to be cancelled. Second term, second of the first term and first of the second term is going to be cancelled. And similarly, second here, the first here is going to be cancelled. So which means at the end you will get cancelled f of minus infinity plus 1. Okay, first term is not cancelled and the last term is also not going to be cancelled, not cancelled. Okay, which remains there. Now we come to the second particular second term, that is this one, in which you have some particular term, first one, second one, third one. You see the pattern. F of 1, the first one in the first, f of 1 minus f of 1, that is the second one in the second term in the second. Like you see, the first here, second here are going to be cancelled. Similarly, you see first here and second here, f of 2 minus f of 2 is going to be cancelled. So the first and the last is going to be cancelled, hence this is going to be cancelled. Okay, similarly f of 3 is cancelled, f of minus 3 is cancelled, like all the terms cancelled. Now the second one and the last term, the first one remains. So in the first one and the last one remains. So hope you understand. Now you see the two terms. This is f of 0, this is minus f of 0. So hence these are all cancelled. These two are cancelled. And only the terms remains f of infinity plus 1 minus f of infinity. It is equivalent to be write f of infinity plus 1 minus f of minus infinity. This is equivalent to be 1. Now I simplify again. That is, I change the term in in terms of the one particular specified pattern. That's all. So what is infinity plus 1? It is again infinity. So therefore f of infinity minus f of minus infinity is equivalent to 1. Let you consider equation 1. I have considered f infinity plus 1 as infinity, f of infinity minus f of minus infinity is equivalent to 1. So this is what the first equation I got. Now I have to calculate the values of f of infinity, f of minus infinity. So now I use various kinds of results and properties of the probability as well as distribution function, so that I write all the properties for infinity and minus infinity, right? So that I arrange this and so that I come to a conclusion that what are the values of f of infinity and f of minus infinity, right? So now if I consider, you see here, minus infinity is also a one particular value. For minus infinity, if you consider f of minus infinity, value is lies in between 0 and 1, 0 less than equal to f of minus infinity less than equal to 1. Since for any particular value of x, distribution function lies in between 0 and 1. That is one of the property of distribution function. Similarly, for infinity, 0 less than equal to f of infinity less than equal to 1. We can consider that. Okay? And if you consider f of minus infinity, for minus infinity is always less than infinity. I write here. Let you consider this is equation 2. Right? And if you consider minus infinity is less than, always less than infinity. For x is less than y, another property of distribution function states f of x is less than f of y. That is f of minus infinity is less than f of plus infinity. Let you consider equation 3. F of minus infinity is less than f of infinity. F of minus infinity is also less than between 0 and 1. F of infinity is also less than between 0 and 1. And f of infinity minus f of infinity must be equivalent to 1. This is the base equation. We got this particular equation from the result we have taken. And minus infinity less than infinity, then f of minus infinity less than f of infinity. So I write here f of minus infinity is less than f of infinity. This is equation 3. I write two more equations. Based on this, f of minus infinity is always greater than or equal to 0. I consider. For time being, I consider it is greater than or equal to 0, and f of infinity it is less than or equal to 1. So I can also consider this is another equation, equation 4. Since it is greater, for every value, probability or distribution function is greater than or equal to 0. For any particular value, distribution function is less than or equal to 1. So it is greater than or equal to 0. Minus f of minus infinity, f of infinity less than or equal to 1. Like that, which value satisfies f of infinity minus f of infinity is minus f of minus infinity is equal to 1. That is, for example, you consider this is x, this is y. X is less than 1, y is greater than or equal to 0. X minus y is equal to 1. Therefore, only therefore only two values exist for x and y. X is equal to 1, y is equal to 0. That's all. X is equal to 1, y is equal to 0. You see here, I support all the conditions, all x and y, whatever x and y you consider f of minus, let us consider this is x, this is y. X is lies in between 0 and 1, y is also lies in between 0 and 1. X y subtract cheste 1 రావాలి మళ్ళీ. X y subtract చేస్తే 1 రావాలి. X y 0 కి 1 కి మధ్యలో ఉండాలి. అలా x minus y చేస్తే 1 వచ్చే వాల్యూ ఏంటి? Only 1 0. This is 1, this is 0. That's all. So therefore, from all the four equations, f of minus infinity is equal to 0 and f of infinity is equivalent to 1. Hope you understand. From all these equations, by referring 1, 2, 3 and 4, f of minus infinity is taken as 0, f of infinity can be only 1. It can be taken as the value 1. F of infinity is 1, f of minus infinity is 0. This is another important property of distribution function. Hope you understand. This is what the another important property of distribution function. The proof of this particular properties also I explained in this class. So total there are 7 properties we have for the distribution function. We have discussed in 2 particular parts. So this is end of this particular part 2. So hope you understand these are the properties of distribution function. Thank you.